Okay, this is Introduction to Probability, and this will be the first video for Unit 3A. We will have some review videos from prior topics that we've covered that we'll put into this unit. So probability is a ratio of comparing what you want to happen to the total number of possible outcomes, or how likely something is to happen. So all probabilities will range from 0 to 1 inclusive. That's something we've talked about before. So basically, equation-wise or concept-wise, probability equals the number of favorable outcomes divided by the number of total possible outcomes. In other words, what you want to happen versus all the things that could happen. Once again, as I said just a moment ago, the probability of the impossible is 0 or 0%, and the probability of something guaranteed to happen is 1 or 100%. And all those probabilities must sum to one whole. So the sum of all possible will sum to one whole. They'll never be negative, and they'll never be greater than 1. Random phenomenon. Random phenomenon is just not randomness, but it is the possible outcomes that are known. For instance, when we roll a dice, we know that the possible outcome would be getting a 1, 2, 3, 4, 5, or 6, but the actual outcome is unknown. So we know the possible outcomes, but we don't know which particular outcome will occur. So that's random phenomenon. Sample space is a list of all the possible outcomes. So rolling the dice, our sample space would be 1, 2, 3, 4, 5, and 6. And flipping a coin would be just as simple as heads and tails. Now, we're going to introduce a little bit of sample space in this video, but we're going to go into great details in like the 4th video. So a trial, this is just like we had in simulations at the very beginning of the year. It is what we are repeating or doing over and over again. It could be the roll of a dice, the spin of a spinner, etc. But it's what we do over and over again. Law of large numbers. The law of large numbers basically states that as we do something over and over and over again, it gets closer and closer to the theoretical probability. It gets closer to what we would expect to happen. Please note, it does not apply to an individual trial or an individual event. It applies to the great group of trials where we do them over and over again. For instance, flipping a coin, we know that we're going to get heads 50% of the time. But if I only flipped it 4 times and I got 3 heads, no one would be totally freaked out. But really, that happened 75% of the time, and it should have only happened 50% of the time. However, if we were to flip it by 1,000,000 times, we might have 50 too many heads, but as a percentage, we're going to be at about 50.1, or somewhere between 49.9% or 50.1%. So as we do something over and over again, we're going to get closer and closer to the theoretical. And that's the law of large numbers. You need to put a big star by that. That's a very important concept. And once again, it's to say that what we do over and over again will get closer to the theoretical. Also, please remember what we've done in the past will not affect the future if events are independent. For instance, when I flip a coin, I may have gotten 3 heads in a row. Well, the probability the next one is a head is still 50%. All right. Probabilities don't change if the events are truly independent. But the law of large numbers does say that on the whole, if we do it over and over again, we expect 50% to be heads. Once again, we're going to look at independence right now, just kind of briefly. We'll go into greater detail later on when we get to the classical part of probability. But independent events in which one probability does not impact the other. Prior to this, in our prior unit, we talked about them being proportional. We've talked about events being proportional, and we said we could show those things, proportionality on a segmented bar chart, where the segments from corresponding segments were of the same size. The multiplication principle: if 2 events are independent, their probabilities can be multiplied to find the likelihood that both events will occur. And basically, Up until now, when you were working in middle school and probably in elementary, you multiplied probabilities frequently, especially in middle school. And you just multiplied them because the events were independent. And if events are independent, you can multiply them. And we have this little formula that you will need to memorize. It's the probability of A and B equals the probability of A times B. Well, notice we have the little intersection symbol. So that's the symbol for intersection. It also means and. All right. And this is where the overlap occurs. This is where probability of A and B equals the probability of A times B. This is only true if events are independent. So the only time you can multiply events is if they are actually independent. All right. So the multiplication principle, there's a limitation. Events must be independent. Please do not use unless they are. Also, basic probability hint that I'm sure you heard in middle school. Or means add and means multiply when doing probability. Now that said, that's a rule of thumb. In general, that is the case. Most of the time that holds true. So that's a good hint word. It's not a guarantee word. So let's look at a couple. A fair number cube is rolled and a fair coin is tossed. When they talk about a fair number cube, they're talking about a six-sided die cube that has six sides, and they're talking about it. And basically, what I could get is a 1, 2, 3, 4, 5, or 6, and on the coin, I could get a heads and a tail. But they use the word and. Oh, and means multiply. Well, I can only multiply if the events are independent. Well, I'm pretty safe at saying, it feels pretty safe saying that rolling a die and flipping a coin are independent and that the dice doesn't impact the coin and vice versa. So what they asked is, what's the probability of rolling a 3? Oh, rolling a 3. That means I'm rolling a 3. And I like to make a space for every event that they asked for. So since they asked me to roll a 3, I'm going to make a space. And getting a tails. Well, the probability of getting a 3 is 1 out of the 6 values. And getting a tail is 1 out of the 2 possibilities. And since they use the word and these events appear to be independent, I can multiply them, and I just get 1/12. On the next problem, what's the probability of rolling 2 4s, followed by tossing 2 heads in a row? Well, right away, I'm going, well, wait a second. I'm doing 1, 2 4s, and 2 heads. Now, again, rolling a dice, flipping a coin, they're independent. So I feel like I can multiply these. I have 4 spaces, 1 for each of the 4s, and a probability of getting a 4 would be 1 out of the 6. And the second 4 is also 1 out of the 6 because they're independent. Probabilities didn't change. And tossing a head, well, that's 1 out of 2 and 1 out of 2. And I can multiply them directly, and I end up getting 1 out of 144. And by the way, this is work shown. Now, technically, you don't have to draw the blanks. I just find that when I fill in the blanks, I end up doing better. So it usually helps when I make a little list of what could happen, then I fill in the blanks for the things that could happen. So part C, what is the probability of rolling a 5 or a 6 and then tossing 3 heads in a row? Here we have a new phrase, or. Well, we indicated earlier that or probably means add. So I need to roll a 5 or a 6. And then I need 3 blanks for getting the 3 heads in a row. Well, the probability of a 5 is 1 out of 6. The probability of a 6 is 1 out of 6. And then the heads would be 1/2, 1/2, and 1/2. And notice, followed by rolling 2 heads in a row. Well, how do I know that I'm supposed to be multiplying? Well, it's the probability of getting a 5 or a 6 and then getting a head and a head and a head. And even though they didn't say the word and, it was implied, so I need to be multiplying those. And when I do that, I end up getting 1 out of 24. The next thing, it says a bag contains 3 A's and 5 B's. So that's 1, 2, 3, so 3 A's and 5 B's. What is the probability of drawing an A, rolling a 6 on the dice, and tossing a tail on the coin? Well, how many things am I doing? Well, I'm drawing an A, I'm rolling the dice, and I'm tossing a coin. Drawing an A would be 3 out of the 8, so 3 eighths. Rolling a 6 on the die was 1 out of 6. And getting a tail is 1/2. And since I have to do an A and a 6 and a tail, I'm multiplying them. All right, so it's going to be 3 eighths times 1/6 times 1/2 equals 1/32. All right, what is the probability of drawing a B and getting a heads on the coin and either a 2 or a 3? So here we're asking for, what are we asking for here? We're asking for a B, so that's one thing. A heads, that's another. And then either a 2 or a 3, and or means add, so that I need a blank plus blank. So the probability of getting a heads, a probability of getting a B would be 5 out of 8. A tail on the coin, a heads on the coin is 1/2, and a 2 is 1 out of 6, and a 3 is 1 out of 6. The or indicates I'm supposed to be adding. Here I have and, so we know we're multiplying. Regardless of how many things I have, I will never end up with a probability of greater than 1. If I do, I have a major error. All right, and I need to go back and find it, because you cannot have probabilities greater than 1. All right, thank you.